A knowledge base that updates every week pulls you one direction. A writing voice built over 5 years pulls you the exact opposite direction. Same company, same data, and the deciding factor is a single qualifier word in the scenario. That's the setup. This is Amazon Web Services AI Practitioner Prep from Stack Lessons. By the end of this checkpoint, you'll be able to pull the right applications decision out of your head under pressure from a business scenario in seconds. This is the largest domain on the Amazon Web Services Certified AI Practitioner exam, so we're running 5 scenarios through the same drill. Read, find the qualifier, eliminate by name, and land the answer. Over the last several episodes, you built the entire applications toolkit. In episode 12, we covered temperature and the sampling dials. In episodes 14 and 15, we drew the line between retrieving fresh documents and retraining the model. Episode 16 mapped out the evaluation metrics, and episode 17 separated a model that answers from one that acts. This checkpoint isn't new teaching. It's retrieval practice, because recognizing a concept on a slide is not the same as pulling it out when 4 options are staring back at you. Every scenario runs the same 4 beats. First, read the situation and pause before you even glance at the options. Second, hunt for the qualifier, the one phrase that quietly locks in a single answer. Third, eliminate each wrong option by name and by reason, not by gut feel. And fourth, confirm and move on. Real exam questions wrap the concept inside a business story, so training this rhythm matters more than memorizing definitions. Here are the 5 decisions we'll drill. Changing facts versus stable style, that's RAG against fine-tuning. Consistent factual output points to low temperature. Summarisation evaluation points to ROUGE. Grounding with source citations points back to RAG. And multi-step actions across systems points to agents. These 5 rules cover the most consistently tested ground in the whole applications block. So let's earn each one. Scenario 1. A company runs an internal assistant that answers employee questions about human resources policies. Those policy documents get revised and republished every single week. The team needs answers to reflect the newest version the moment it lands. The options are retrieval augmented generation, fine-tuning, or prompt engineering. Pause here and pick your answer before I walk through it. The qualifier is 2 words. Updated weekly. That's the entire question hiding in plain sight. When knowledge changes on any recurring schedule, weekly, daily, hourly, you need to retrieve it fresh at query time, not bake it into a model. Changing facts on a schedule means retrieval, not retraining. Everything else follows from spotting that phrase. Let's eliminate. Fine-tuning is out because retraining a model takes hours to days. It can't possibly track a weekly cadence. Prompt engineering is out too because pasting entire policy documents into every prompt doesn't scale and still leaves you re-editing prompts each week. Both of those either bake or stuff the knowledge instead of retrieving it fresh. The answer is RAG. It pulls the newest chunks at query time, indexes new documents in minutes, and when you see Amazon Bedrock knowledge bases in an option, that's your service queue. Amazon Web Services prescriptive guidance puts it plainly. RAG incorporates the latest documents in a few minutes, while fine-tuning can take a few hours to days, so it may not be a good solution when your documents change frequently. That operational gap, minutes versus days, is the official reason RAG wins any scenario built around frequently changing knowledge. Now flip it. A different team wants the model to write in one consistent house voice. That voice was developed across 5 years and a stable body of approved examples. The wording, the tone, the cautious style, all of it needs to be internalized, not looked up. Same 3 options: RAG, fine-tuning, or prompt engineering. Notice the data is still company data. So which one now? This time the answer is fine-tuning. A stable style you want baked into the model's behavior is exactly what fine-tuning is for. RAG would retrieve old examples as documents, but it wouldn't reliably reproduce the tone. Notice what changed between these two scenarios, not the data type. Both scenarios use company data. The qualifier changed. Changing facts versus stable style is what decides it, every time. Here's the picture to lock this in. Think of 2 ways to make a chef better. RAG is handing the chef today's menu and ingredient list right before service. The knowledge is external, current, and swapped out daily. Fine-tuning is sending that chef to culinary school for a year to internalize the technique. The style is baked in and doesn't change day to day. Weekly policy updates, hand over today's menu, consistent house voice, culinary school. That single split covers the most tested decision in the whole domain. Scenario 2. A medical summarization tool must produce consistent, accurate summaries. The same input should yield the same faithful output. No variation, no surprises. The question asks which inference parameter setting delivers that determinism. The options include low temperature, high temperature, and top K. Run the decision rule from episode 12 before I give it away. 2 distractors, 2 clean reasons. High temperature is out immediately. It flattens the probability distribution and adds randomness, which is the exact opposite of what a medical summary needs. Top K is subtler. It narrows the candidate token pool, but it doesn't force the single top token, so it can't guarantee repeatable output on its own. The answer is low temperature. It steepens the distribution toward the most probable token, and near zero it approaches greedy, deterministic decoding. Consistent and accurate means turn the dial down. Straight from the Amazon Bedrock Inference Parameters documentation, a lower temperature steepens the function and leads to more deterministic responses, and a higher temperature flattens it and leads to more random responses. If you've ever felt that direction was backwards, this is your anchor. Lower is more deterministic. That confusion is one of the most persistently tested errors in this domain. Scenario 3. A team built a new summarization feature. They want to automatically score their generated summaries against human-written reference summaries. The question is, which evaluation metric fits? Your options are ROUGE, Blue, accuracy, and the F1 score. Got your pick? Let's see. One word in this scenario eliminates 3 options. Blue is out. It's a precision metric built for translation, not summarization recall. Accuracy is out. It's a classification metric that scores predicted labels, not generated text. And the F1 score is out for the same reason. It's classification, measuring label correctness, not content overlap. The answer is ROUGE, the recall-oriented overlap metric against reference summaries. The single-word summarization locks it in. Here's the memory hook that makes this automatic. ROUGE literally stands for Recall-Oriented Understudy for Gisting Evaluation. The word recall is baked into the name. It asks how much of the reference summary actually made it into the output. Blue, by contrast, is translation precision. Summarization maps to ROUGE, translation maps to Blue, and the full name is the clue that survives exam pressure. Scenario 4. A legal chatbot must answer questions and cite the specific clause behind every single answer. Lawyers need to trace each response straight back to a source document. And here's the twist this time. The document set itself is fairly stable. It isn't changing weekly. Your options are RAG, fine-tuning, or prompt engineering alone. Think about which constraint matters most here. This is the detail that catches careful people. The documents are stable, so your instinct might drift toward fine-tuning. But the citation requirement, all by itself, selects RAG. A fine-tuned model produces no source references at all. It speaks from internalized weights with no footnotes. So even when the knowledge never changes, needing to cite the source is a distinct qualifier that points straight to retrieval. Let's eliminate. Fine-tuning bakes in behavior but returns no source references, so it's out. Prompt engineering alone can't guarantee grounding against a private document corpus, so it's out too. Neither one returns a citation a lawyer can actually verify. The answer is RAG. It retrieves the source and returns a reference to it. It grounds the answer to reduce hallucination risk. And Amazon Bedrock Knowledge Bases returns those cited answers natively. Amazon Web Services prescriptive guidance draws a clean line between the two approaches. A RAG model provides a reference to the information source in its response. A fine-tuned model does not. That single distinction is decisive. Whenever a scenario demands citations, grounding, or verifiable sources, fine-tuning is off the table. Scenario 5. A company wants to automate a multi-step procurement workflow. The system has to check inventory, call a supplier's application programming interface, update the enterprise resource planning system, and then confirm back to the user. It has to take real actions across systems, not just describe them. The options are an agent or a plain foundation model response. Lock in your answer before I reveal it. The whole scenario turns on answer versus act. A plain foundation model response produces a single block of text from a prompt. It cannot call an external application programming interface, and it cannot update a database or any downstream system. So it's eliminated the moment the workflow needs to do something. The answer is an agent. It reasons through a multi-step goal in a reason, act, observe loop, calls tools and APIs in sequence, then synthesizes the result. Your signal words are automate, multi-step, call APIs, and update systems. One lifecycle note worth carrying. The decision rule never changes. Multi-step actions across systems means an agent, but the service behind it has moved. Bedrock Agents Classic entered maintenance mode and is closed to new customers, and Bedrock Agent Core is now the recommended platform for new implementations. On the exam, if you see the word agents in an answer option, it still signals action execution. The wrapper changed, the concept did not. Here are all 5 rules in one view. Changing facts or required citations point to RAG, with Bedrock knowledge bases as the cue. Stable style or behavior you want internalized points to fine-tuning. Consistent, factual, deterministic output points to low temperature. Summarisation evaluation points to ROUGE, while blue is for translation. And multi-step actions across systems point to agents, with Agent Core for new builds. If you remember nothing else, remember the RAG versus fine-tuning qualifier and the temperature direction. Those two carry the most weight. Now let's put it to the test with a quick 5-question quiz. All right, time to put your knowledge to the test. Question 1. A retailer wants a foundation model to generate product descriptions that match its distinctive brand tone, learned from a fixed library of 10,000 approved past descriptions. That tone rarely changes. Which approach best fits? Is it A, retrieval augmented generation over the approved descriptions? B, fine-tuning on the approved description library? C, prompt engineering with a single instruction? Or D, lowering the temperature parameter? Pause here if you want more time. This one is B. The goal is a stable internalized style, not fresh facts and not citations. Fine-tuning bakes the brand voice into the model's weights. RAG would only retrieval descriptions as documents without reliably reproducing the tone, and temperature just controls randomness. Question 2. A compliance assistant must return the same precise, factual answer every time it's asked an identical question, with no creative variation. Which inference parameter setting best supports this? A high temperature near 1.0. B, a moderate top value. C, a temperature near 0. Or D, a high top pi threshold. Lock in your answer before I give it away. The right call here is C. A temperature near 0 steepens the distribution toward the single most probable token, giving you deterministic, repeatable output. High temperature would add randomness, and neither top nor top forces that top token by itself. Question 3. A team is building a feature that condenses long research articles into short abstracts, and they want to automatically score the generated abstracts against expert-written reference abstracts. Which metric is most appropriate? A, ROUGE. B, blue. C, the F1 score. Or D, accuracy. Think about which task this really is before you answer. The answer is A. Condensing articles into abstracts is a summarization task, and ROUGE is the recall-oriented standard for summarization. Blue targets translation precision, while F1 and accuracy are classification metrics that don't apply to generated text at all. Question 4. A financial advisory bot must answer client questions and include a citation to the specific internal document behind each answer, so advisors can verify the source. The document set is stable. Which approach is required? A, fine-tuning on the internal documents. B, prompt engineering alone. C, continued pre-training on the document corpus. Or D, retrieval augmented generation. Got your pick? Let's see. If you said D, well done. Only RAG retrieves the source and returns a reference to it in the response. Amazon Web Services guidance says fine-tuned models provide no source citations. Prompt engineering alone can't guarantee grounding against a private corpus, and continued pre-training produces no citations either. The stable document set is a distractor. The citation requirement alone decides it. Question 5. A company needs an AI system that, from a single user request, will query a shipping application programming interface, reserve a delivery slot, update the order record in a database, and email a confirmation. Which solution fits? A, an agent that orchestrates multi-step actions across systems. B, a plain foundation model invocation. C, a RAG pipeline over the shipping documentation. Or D, a fine-tuned model specialized in logistics language. Run the decision rule from earlier before you answer. It has to be A, and here's why. The request requires taking actions across multiple systems. Calling APIs, updating a database, sending email, and only an agent can orchestrate that sequence. A plain model call, RAG, and fine-tuning all produce text, but none of them can actually execute those steps. The signal words automate and multi-step across systems point straight to an agent. And checkpoint 3, foundation model applications retrieval challenge is sorted. If you want the rest of the Amazon Web Services AI Practitioner prep without searching, subscribe and YouTube handles it. Tell me what clicked and where I lost you. I read all of it. Suggestions for the next course are always welcome. Just name the exam. And if anything about the pace or the look would work better, let me know. Thanks for watching. See you soon.